Okay, the next thing that I want to explain is about data crawling. Okay. So what is data crawling? We call data crawling. It is to collect data from multiple websites or pages. So if we want to collect from web, then we call it crawling. Sometimes people say it is scraping. But data scraping is focused on specific elements on a single web page. Now, let's see if I have this website. Okay, let's just use the very easy website. So this website contains posts. Like this one, this is a text from our instinct. The world as we have created, it is a process of our thinking. It cannot be changed without changing our thinking. Okay, so this is code. Now I want to scrap. So I want to get the data from the web and I want to put it into maybe CSV or some of my data format. Then I give you one example so you can check this one. So this is the code. Now you don't need to understand the code, okay? Because actually you can ask Gemini and then Gemini will generate the code. So this is the example. Let's say I run this code. It uses the beautiful soup, and then after you run this code, you will get the data. Okay. So we use the URL from this one, and you get the data. So we call this is scraping, or we call this is crawling. So if you have data from maybe Naver, if you have data from Kakao, from Dao, and you want to get the data, so you can do also like this. One scraping. Yeah, you can ask Gemini. Okay. I want to crawl data from, let's say, yeah, you can give this like this one. Show me the Python code. Then it will show you the code. I think it's similar with this one. Then you can copy and paste this code, and then you can directly get the data from web. Some web may not be available because they have some security. But I think if this kind of web, it is still free for you to subscribe. Okay. So next thing is I want to mention about data engineering and data quality. And we need to understand the term big data. What is big data? So I would like to explain about the data quality, 6 dimensions of data quality, and the 6 P in the big data. So data quality. What is data quality? Data quality means how well data fits its purpose in AI, analytics, and decision making. So if your data is good, high quality data, then it means it can ensure the accuracy, it is reliable, and then it can produce the efficient AI model. If your data is poor, then it can lead to bias and incorrect insights, not correct insights. So there are 6: accuracy, completeness, consistency, uniqueness, integrity, and validity. accuracy. What does it mean by accuracy? Accuracy means the data correctly represent the real world values. So, for example, a customer name and address in the database should match the official records. So, if you have your name in this university, okay, for example, yeah, one name. Okay, I give example like this one. There is a student name, John Doe. So, based on this ID and based on his passport, his name is John Doe. But maybe in different country, they need to fill out the family name first and then the first name. So the name is Joe John. This will be a problem about the accuracy. It happens sometimes. For example, in your Tenukju, you will see your family name first, Kim Jong Won. Then Kim will be at the first. But in your passport, your passport, then you will see Jong Won Kim. Kim will be at the end. So that kind of thing, it may give some data accuracy issue. Completeness. Some data has no missing or incomplete values. So you can see a medical data set missing patient kits or diagnosis details, it reduces the usability. So if data like this one, no data, missing, zero. Okay. So we need to be careful. If the data is not in a good quality, then you may have some effectiveness will be reduced. Consistency. So the data should be uniform across different sources. So let's say in the financial department, John got the salary 1,000. But in the human resources department, John got the salary 2,000. So when we want to analyze the data, in one database, it mentioned John got 1,000. In different database, it mentioned John got 2,000. So it is inconsistent. Then we need to be careful with this consistent data. Uniqueness. So duplication or overlapping data is identified and marked. So whenever you have a student ID, so your student ID will be very clear. 2005, maybe 99911. So is there any similar or is there any the same student ID or different name? The same ID, name Kim. The same ID and the name is found. Is this possible? No. One ID, one name. Then, if there is a double or duplicate like this one, so the ID is 1001. The name is John Doe. The ID is 1001 and the name is John Smith. Okay. We should pay attention if there are some duplicating like this one. Integrity. So the data maintains logical relationship and connection across different data sets. For example, your office hour is 9 until 5. But the data that is still complete after 5. So ID 1001 complaint is about the defect product. And the complaint comes at 70 or 7 p.m. Then it means this might be some integrity issue. The office hour until 5, but why there is a complaint at 7 p.m.? Validity. So the data follows the correct format and standards. For example, email, email should be with at will be. If there is no at, then it's not email. Okay. So when you have email, if you have no company, then it's error. It is not. And they, in Korea, you have the format YYYY, MM, DD. So year, month, and date. But the format is like this one: 99999999. Then this will be invalid. Okay, so the validity should be correct. So, yeah, maybe in the exam, I will give you example like this one. So find about the data quality issue. What is the issue here? Okay, for example, here, the country is US, but the city is Seoul. So this is inconsistent. This one, the data is missing, so it is not complete. This one, the student ID 1000, 1001, 1002, 1003, 1004. But suddenly we have 2 of 1001. So it is the uniqueness issue. This one, we know that 1005, 1005 is the same ID, but the postal code is different. And the status also different. So this might be inconsistency. This might be the this might be inconsistency. This might be the integrity issue. City. So we have a lot of names like Seoul, Jakarta, Busan, Washington, Yongin. But suddenly we have numbers. So this is not accurate information. Okay. So yeah, there might be one question, something like this one. If you understand the quality, there will be no issue. So big data. What is big data? A big data is a collection of data from various sources. So the well-known characteristics are 3V: velocity, variety, and volume. Over time, other V's have been added to the description of big data. So we have velocity, value, and variability. So let's see. Velocity. So we call velocity because the data is available in various ways. For example, in the batch. Batch is just one at the same time and finish. But maybe the data can be near time means you can get at 10 a.m. You can get the data at 11 a.m. You can get the data at 12 p.m. So every schedule there can be a date. Or the data can be real time. So the data in real time, for example, music data. So it will be a real time data. You will get the data every second. Streaming. So if you look at YouTube or news, SBS, PBS, MCC, they have the live streaming about news. So then we call it as streaming. So if those things happen, then it is related with big data. The other thing is about the variability. The variability we learned previously. Some data is structured, some data might be unstructured, and some data might be semi-structured. So if it is video data, like this one, it will work. So actually, this is a video. So it is cooking class. So in the cooking class, we can see time. From this time until this time, she explained about this one. From this time until this time, she explained about this one. From this time until this time, she explained about this one. And it is a combination of the structure, unstructured, and semi-structured. So the validity of the data, if it is a combination of those, then it is considered as big data. And volume. So volume means the data is in the high dimension. So there are many columns. The data is huge in the records. There are many rows. And usually it is the transactional data. Maybe the size it can be like so you know the megabyte, gigabyte, terabyte, petabyte, exabyte, zettabyte, yottabyte. So this is the size of the byte. Megabyte is the smaller. If it is only 5 megabyte or 10 megabyte, it is small. But when the data size increase, then it becomes bigger and bigger, and you need to have a good computer to analyze the data. Your current laptop may not be able to analyze gigabyte data. Maybe your laptop can only analyze megabyte. If you want to analyze the gigabyte, you need a good computer. If you want to analyze the petabyte, of course you need to have a really good computer, maybe super computer. If you want to analyze the petabyte, maybe you need to go to Google to analyze the data. If you want to analyze the other data, you need to buy some quantum computer. Okay. This is very big in the volume, so you need to think for your project which data is good for you. If you want to choose the gigabyte data, no problem, but please check your computer. If it is not good, then just find the data with megabyte. Okay. Don't do with the very big data for your analysis. The other P is about veracity, value, and variability. The veracity means whether the data is reliable or not, whether the data is trusted or not. Trusted data. Data. So where is the data? If the data is about health, then it should be from maybe hospital. If the data is about law, then the data should be from maybe the court. If the data is related about education, then we need to ensure that data may be from university and etc. Okay. Value. So whether the data has value or not. What is the business value? Let's say in the healthcare, health, we have the clinically relevant data. So we want to know how to analyze cancer. Then of course, we need to check some information from hospital. We need to check some information maybe from the government. Okay, we need to get the value from the data. And some more important is the longitudinal studies. We call it longitudinal, it means long. Long means we took the data in many years. So it is not only 1 year, 2 years, but maybe 10 years, 20 years. Okay. So if you get the data in many years, then the value will be very high. And so that's what we call as the longitudinal studies. So usually people do these things in the, cancer. It is very difficult. So you need to get the data every year, and then you need to do research maybe 20 years, 30 years, maybe 50 years. And last one is about the variability. So the big data format, it also affects the big data. You cannot use CSV for big data, because if you use CSV, your computer will be very slow. Some formats are available in the big data. Or if you learn about later some big data, you will know about data lake. Everything is inserted into the data lake. So Google, Amazon, we have the storage for data lake. The variability, maybe you have data, but you have only spring data, or summer data, or only winter data. So it means the variability should include all seasons data. Now, let me play some game with you. Have you ever heard about this teachable machine? So, I would like to play a game. In this website, you can create your own data, and this machine can directly predict something about image, about audio, about your post. So let's see. I will create image. So they have some requirement, whether it is a standard image or static. Maybe it is already generated image. Let me use it. Okay, so we can collect the data. Now I want to distinguish these three items: black, blue, and red. Okay. So I will turn on the webcam. Now, let me just put it. Okay. So I will go like this one. Okay. So I collect the data. Okay. Okay. Now we have the class. We call it black pen. Maybe just black. Okay. And then let me just go to the second class. Let's check red. Okay. Now I want to check the red color. Okay, I need to make some variation. Okay. Now I want to make a new class. Let's say this is blue. Okay, and then I open the webcam, and then I collect the data. So this is good. Okay. Now let me accept. So you can see the model can be generated. It depends on your data. If your data, then the model generation will be small. If your data is small, model generation it will be fast. Now you can see now there are black, and blue. So the black one is good, but they are not low. Is it? Nothing. Now I will put the black color, and then it shows black. Okay. I give the blue color, then it shows. Oh, they cannot distinguish black and blue. Okay. What about red? They can distinguish red. Okay. So it means your data is important. If you put black, so it's still blue, right? But this one, the AI is more confident that this is blue. But when I put the black, yeah. So the model is not confident. But if I put like this one, the model is more confident that it is black. Why? Because you need to look at the data. When I put the data here, the way I grab the pen, it affects the model. Okay. So not only the color, but how I grab the pen, it affects the result. So the data is important. Okay. Okay. Now I will just stop the recording.